Alright guys, so this is where we ended our notes today. We did an example of elasticity in demand. So if you remember, the formula is to calculate our change in price, which is the original price minus the new price over the original times 100. In step 2, we calculate the percent change in quantity demanded, or delta QD, and do the original quantity demanded minus the new quantity demanded over the original times 100. In the final step of this process, we take the percent change in quantity demanded, delta QD, over the percent change in price, delta P. I did this example in class where I had my original minus new. We were looking at the price change from $4 to $8. $4 would be my original price, $8 would be my new price. $4 would be my original quantity, and 2 would be my new quantity. So I did the math here, simple stuff. Remember that when we are dealing with elasticity of demand, we're going to be dealing with the absolute value, so positives. So it doesn't matter if when we're doing this math, if we take 3 minus 9, we're not going to have negative 6. We'll have just 6. Okay, this is math terms here. Okay, so we're going from x to y in this example here. That makes our original price. We're going to go from $12 down to $10. And then our original price is 4, or original quantity, sorry. And new quantity is going to be 5. That's an N, by the way. All right. So, my formula is original minus new over original times 100. So these are the same things that you're going to be looking at when you look at the homework for today, which, if I can pull that up real quick. I can't, apparently. Looks like this, okay? So as you're going and looking at these 4 questions where it's dealing with elasticity of demand, make sure you read the question from $2 to $4. Okay? So when you're looking at your examples, what is the original? It's going to be the first price listed. So $2 will be my original price, which means that 6 is going to be my original quantity demanded. Here, I'm going to move into $4. $4 is my new price, and 2 is my new quantity demanded. On your homework, you're going to need to plot the points as well, and you have some space to do the math, okay? So that will be the same for all of these. Follow what's here. Ignore this column. It's there to distract you, okay? I want to make sure that you know what numbers you need and what to look at, okay? Here we're not jumping all the way from one end to the other. We're just going from 100 to 150 in your homework, okay? So, back to this example here. If I do it here on this, it might be better. Okay, so again, moving here in this example from x to y, we're looking from 12 being our original and 10 being our new, which makes our original quantity 4 and our new quantity 5. So our formula is original minus new over original times 100. I'm sorry that this looks so terrible. Okay. If at any point as well you need to pause the video, rewind this, please do so. Okay? All right. So we're going to calculate delta P first. So our original price is 12 minus 10, our new price, over 12 times 100. So if I take 12 minus 10, that's 2 over 12 times 100. That's 1/6 times 100. And 1/6, 1 divided by 6 is 0.16, repeating, times 100 is 16.6. So that's my delta P. And those are lovely 6s. Now we're going to look at the change in quantity demanded. So moving from 4 to 5. 4 minus 5 over 4 times 100. So this is where we run into that scenario with the needing absolute values. 4 minus 5 is going to be negative 1, but we're dealing in absolute values, so only positives. So 1 over 4 times 100. And that's 0.25 times 100. It's 25. So that's my delta QD. So now I take delta Q. I'm sorry, there's no pretty way to look at any of this. Over delta P. And that would be 25 over 16.6. So type that into your calculator. And you get an answer of 1.5 as your final answer. So because that answer is greater than 1, that means that the demand for this good is elastic. That means that consumers are very sensitive to a price change for this particular product. Okay? So you're going to have 4 examples of that on your homework. So take your time and work through it. If you need to review this so that you know where you're plugging your numbers again, that's fine. All right. So there's various factors that affect elasticity after a price increase. One such factor is the availability of substitutes. More substitutes available usually means that there's more elasticity, right? Because if I have a lot of options and one price changes, then I'm going to have a huge change in my demand for that one good, right? So back to our Pepsi and Coke example, okay? If I have Pepsi, Coke, I have all these different pop options available to me. Or let's just say in the vending machine at school, there's all those diet drink options, right? No diet, zero sugar drink is your preference, right? You just want a drink from school. So if the price of the Coke Zero goes up to $3 or $4, right, you have all these other options of things that you're going to choose. So if there's a large availability of substitutes, that means that you as consumers will have more of a change in your demand. The passage of time. The passage of time often increases the elasticity in demand because as time goes on, we find other items that can replace that one good. Necessity or luxury. Demand for necessities is inelastic, right? It doesn't matter how high they raise the price on my prescription for my ADHD. I need that prescription in order to function as a normal human being, right? So I will pay that price. My demand will always be one prescription once a month, okay? Whereas demand for luxuries is elastic. As those prices change, those are things I don't need, right? So I'll find other alternatives. Maybe I won't go on a backpacking tour in Europe. I'll just go take a road trip instead and still get to have a vacation. Relative importance to the budget. The greater the impact on the budget, the more elastic the demand. So again, luxury items are going to college, right? If I know that it's going to take a large chunk of my paycheck to go to college and pay back those student loans later, right? I may not consider going to college because it's so much money, all right? So in general, elastic goods, there are lots of substitutes available, would take up more of the budget. These goods are mostly luxury goods. In the long term, substitutes are found and goods become elastic, and your calculation results for this are 1 or higher. So anything from 1 to infinity is going to be an elastic good. In elastic goods, there are few substitutes available. It takes up less share of your budget, right? So packs of gum, right? It doesn't matter that they change the price of gum for $1 to $1.50 for a pack. That's a small amount of my budget, so I'll go ahead if I want gum and I'll just get that $1.50 pack. These are mostly necessities. In the short term, a price change makes consumers continue to buy this good because they haven't found those substitutes yet. The results when we do our calculations for elasticity of demand are going to be between 0 and 1, so they're not going to be whole numbers, okay? And when you're graphing, if you have a line, horizontal line, right, it's going to be perfectly elastic. If you have a vertical line, it's perfectly inelastic because it's making an eye, okay? All right, so effects on revenue. A good producer will look at their product and consider how the price change will affect profits prior to the increase. So if I know that my people are highly sensitive to a price change, I'm not going to want to change the price quickly, right? I may want to just do it a couple pennies at a time. right? Their total revenue, the total amount of money a company receives by selling goods or services, so the money that they make, will be affected by a small margin or a large one, depending on how elastic the good is. Total revenue, TR, is calculated by the formula below. It's simply the price times the quantity. So simple multiplication here, right? And if we know the quantity and the total revenue, we're going to divide to figure out the price. Okay, so this is just some basic algebra here, which you do have questions like that on your homework as well. So looking down, after number 4 is this chart where you're looking at this. So 1 times 25, right? What is my total revenue? Price times quantity demanded. 1 times 25 is going to be 25, okay? But going backwards, if I know that my total revenue is 40, my price is $2, 2 times what equals 40? 20, right? Okay. Moving along, I'm at about 11 minutes here. I only have 15 minutes per video. All right, so again, this is just showing you a demand schedule, kind of like what you're going to see on your homework, right? 1 times 8 is $8. 4 times 2 is $8. Okay? Right? Notice that there's a big change going from one to the other. Okay? I'm still making $8, but at a certain point I've started to lose money. Whereas here, with an inelastic good like a prescription, it doesn't matter what they raise my price to, I'm still going to demand 2, and so those companies will continue to see an increase in profits if their good is inelastic. So we're looking at effects on total revenue. For an elastic good, that is an inverse relationship. So what you saw here, right? It started to go up. The total revenue, the total amount of money that a supplier would make went up until a certain point, and then they started to lose money and lose quantity demanded customers. Okay? So it's inverse. This is just like our law of demand. However, if it's an inelastic good, the change in total revenue is directly related. Okay, so if the price is lowered, total revenue falls. The price goes up, total revenue rises. Just like what we see here. Okay, it doesn't matter. I'm going to keep raising my price. Quantity demanded will remain the same, and I'm going to continue to see profits no matter what I put that price at. All right, so what are some things that would cause the demand curve to shift? What is the formula for determining elasticity? What is a normal good and what is an inferior good? All right, causes for the demand curve to shift. We talked about this. Changes in income, consumer expectations, changes in demographics or population sizes, consumer tastes and advertising, and prices of a related good. Those are all things, that's not just movement from one point to the other, right? That's just looking at price. Shifts in demand cause the entire curve to shift either left or right, an increase or a decrease, like we see here, okay? What is the formula for determining elasticity? So that is this 3-step process that I talked about. The original price minus the new price over the original times 100. Look, I fixed it. Okay, and then we take the original quantity demanded minus the new quantity demanded over the original times 100. Then finally, we take those two answers, put them together, have delta QD over delta P. Okay, that's our formula, which is on your homework. And then what is a normal good and what is an inferior good? Okay, normal goods are things that as our income increases, we want more of that good. Okay, but if our income decreases, we want less of that good. So some examples would be home cooked meals is a normal good, right? Those items like red meat, if I have more money, I'm going to want to splurge a little bit, okay? But if for inferior goods, if I have less money, then I buy more of these goods, like ramen noodle. Alternatively, if I have more money, inferior goods, I buy less of because I don't want to keep eating ramen noodles. I want better food, okay? So give me a second and we'll have a part 2 video where I keep this going, okay?